We are working on a tube chassis car where everything is built from the ground up, and today we're going to be working on the suspension geometry, exhaust, and finishing the tube chassis. Now we're making custom bearings for the rear because we couldn't get anything off the shelf, but unfortunately I lost all the footage for this, so I'm going to just show you approximately how the process of making these goes. They are made on a CNC machine, machined out of steel. CNC machines use tools like this to carve away material and make the final part that you want. So you start with just a block of steel and then you carve away what you don't want to be there. They are extremely accurate to within about a hundredths of a millimeter. Now I also lost the footage of me assembling the bearing, so here's the video of it being completely assembled and working. And to make the spacing right between the rotor and the hub face, I made this spacer on my own CNC machine out of 70/20 aluminum. Then I made this mock-up of the hub where I have a couple of the finished plate pieces tacked together, and then I made some 3D printed prototypes of some of the plate pieces that I didn't want to cut out yet to just make sure that everything fits right and all the spacing is right and stuff like that. I just ordered an order of laser cut steel pieces because the plasma cutter is kind of stopped working right, so I had to get some of the pieces cut out, and also laser cutting is a lot more precise and a lot better to get get right when you have these very thick pieces. So this is 10mm steel. This is 8, so it would be quite a bit for the plasma cutter. It probably could do it, but it typically takes the fuse in the house when it does cut this thick stuff, so a lot easier to get it cut. The rear knuckles are made from 4mm or 5/32 inch laser cut sheet metal, and that's bent up to match the CAD drawings that I made for it. There are a lot more variables to take into consideration than you might think on suspension components, which is actually why I had to draw up the components in CAD first to make sure that everything was going to fit right. Front A-arms are made of thick wall 1-inch tubing that's reinforced with laser cut plate, but I decided to switch it up for the rear to make it easier for myself. So the rear A-arms are laser cut 4mm plate with only tubes where the threads for the heim joints go. That means I can either directly cut M18 threads in the big tube or press fit in a smaller tube to cut M16 threads into. These press fit tubes also get welded together just to make sure that they never come apart. These tubes can then be welded into the sheet metal structure. Lining up the pickup points right is pretty critical to how the car is going to drive, so I 3D printed a fixture to hold the knuckle in the right place. This means I just have to set my heim joint adjustments to the middle, make sure the pickup points are at the right angle and the right place before I tack them. The pickup points are 3mm plate steel that's boxed in, but if I were to do this again, I would probably just do 4 or 5mm plate on either side, so there's only 2 pieces, which would mean a bit less welding, and it would probably end up just as strong. But that's actually what excites me a lot about this project, is learning about what makes sense to do in real life, because it's a lot easier to think of something or draw something in CAD and think it's a really good idea, but in reality you could maybe do it in a much easier way that would make way more sense and would be a lot easier and cheaper to make. But you only sort of learn this through, trial and error. I have here the tie rods for both the rear and the front. These are the front ones and the rear ones in 70/20 aluminum, which were machined out of, so it's essentially billet, machined on a CNC lathe, turned into this, which is very pretty. Obviously, it was supposed to be just a hexagonal raw stock aluminum, and just with a hole drilled in the end, and then the heim joint goes into here, and you can screw it on with a jam nut and hold its place, or if you need to adjust the toe of the car, you can put a wrench on here and either rotate it one or the other way to push or pull on the actual tie rod. So this end will be links or left-hand thread, and this will be normal thread. So when you screw this one way, it'll spread further apart. If you screw the other way, it'll go further together. So yeah, pretty cool part, especially compared to how it was supposed to be. This is a lot cooler and will be a lot cleaner. I'm debating on whether I'm going to engrave something into this to make it, just a little more custom, just here on the middle or something, but I'm not sure yet, because the actual part will be, let me show you, it will be an exposed part on the car, because all of this will be open, so the tie rod will sit right here, which is going to look pretty cool when you look at the rear of the car, because there's nothing in the way. It'll be mounted about there, so you'll very clearly be able to see it. I welded on a 2.5, I think, inch V-band, and so that means that I can just weld this onto a 90 bend, which I have here, very short one, and then a little bit of just straight pipe, just to get it to fit out the side, and that should be good. Otherwise I'll be able to probably trim this or something like that. Clamp like this makes it a lot easier when you're tacking together stuff like the exhaust pipe, because it's kind of hard to handle and line up right, so this helps a lot. So this is the exhaust all welded up. Only work for what it is, you know. I also think there might have been something with the quality of the stainless, maybe, because the flange welded up pretty good, and then some of the tubes were very thin and somewhat like weird quality in the welds, like almost like crystallized or something. But definitely good enough for what it is.